Very good morning, everyone. A very good morning. Welcome to today's Unit 3 class, all of y'all. Okay, all of y'all, we have now completed topic number 12. Okay, boys, all of y'all. Okay, we are done with topic 12 and now we move on to topic 13. Okay, so topic 13 is a lot different from topic 12. Okay, topic 12, we spoke a lot about manipulating data, dealing with databases. Topic 13 is going to talk about a completely new technology that we use in today's world. Okay. So everybody, can we open it up, guys? Unfortunately, my tab is not connecting to the laptop for some reason. I don't know why. I'm uninstalling and installing it again. So I'll be drawing on my laptop screen. You all have your writing books also with you all, all of you all? Everybody, please have your writing books also with you all. And just give me one quick second to load up another file. So all of you all, moving on to topic 13 over here. Unit 3, topic 13, resources. Okay. Right, everybody, guys, girls, all of y'all. Once y'all, can everyone come down to page number 4, please? Everybody, come to page number 4 and have a look at me below. Everybody. Now, all of y'all, if you take your computers, guys, Adam, can you please put it away and all that and look over here? If you take a normal computer that you guys use, your tab, your smartphone, your laptop, how many operating systems do you have installed on it? You have one operating system installed on it. And inside your smartphone, you have a motherboard, you have a processor, you have storage, you have a power supply, isn't it? You have all these hardware components. On top of these hardware components, you have an operating system installed. Agree with me? These hardware components, Sima, can you turn this way? I can't see you at all now. These hardware components, do you agree, will be of no use if there was no operating system? Now, I have so many components over here. Guys online, I'll send this to you shortly. I have so many hardware components connected to my laptop. I have a projector, I have a webcam, a mouse, a microphone, a trackpad, keyboard, all connected. But these components are all completely useless to me unless I can control them, isn't it? And I can only control them using my operating system. So everybody, I have my hardware, I have an operating system on top of it. So I control this hardware using my operating system. Agree with me now so far? Everyone? This hardware, the keyboard, the trackpad, the speaker, the projector, all that is controlled using this operating system. Okay? Then guys, on top of my operating system, I install programs. Each program performs a specific task for me. For example, I'm displaying this tute using a word processing software. I would access websites using a web browsing software. What do we call these softwares that perform specific tasks for you? You call them application software. Everybody okay with this, right? You have your hardware, you have your operating system, and on top of that, you have various apps. Are we all good? Now, guys, let me tell you all something. When I was doing my practical classes, okay, I had a problem. Students who were using a MacBook. So students who are using the Mac OS, I was very unfamiliar with it. Okay, so if I had a student in the class who was using Mac OS and when they called me and asked me a question, I found it difficult to answer their question because I wasn't familiar with how that operating system works. Everybody okay with that? And right now the laptop I have, boys, girls, everyone, the laptop I have runs a Windows operating system. Okay, so I was so used to Windows that when students started asking me questions using a Mac laptop, I found it very difficult to answer. So now what I had to do is I bought another laptop, which is known as a MacBook. So I have a Windows laptop and I also have a MacBook. Why did I buy that MacBook? To get familiar with the Mac operating system. Now guys, look over here. I have a motherboard, but that motherboard is running only one operating system in this laptop. In this laptop, I have a motherboard that's only running one operating system. I have a processor in this laptop. That processor is running only one operating system. I have a hard disk in this laptop. Everybody look here. If I press Windows E, if I come to this PC, I have installed a 500 GB SSD on this laptop. Everyone with me? I have installed a 500 GB SSD on this laptop, but this SSD is running only one operating system. It's running only a Windows operating system. Give me a minute. It's running only one operating system. Even though it has space to run another operating system, it's running only one operating system for me. Everybody okay with this? And then guys, since I'm having two laptops, portability becomes a problem for me. I have to carry two laptops with me. I have to charge two laptops. When I use both of them take double the space on my table. Previously, I had only one laptop. Now with two, double the space is being taken. My purchasing cost was more than double because a MacBook is about almost 3 times the cost of what do you call a Windows laptop. Everybody okay with this? So high setup costs, maintenance cost, electricity, okay, disk space. I'm running into a lot of problems when I'm having two laptops with me. Okay, what were you going to say? No, Adam, you raised your hand. SSD is a solid disk, solid state drive. Hard disk. No, this laptop doesn't come with a hard disk. So this laptop, as you can see, it's quite slim now. So they don't have a hard disk in it. HDD, hard disk driver. So everybody, you all see the problem I'm in, right? I'm having to carry two laptops with me so that I can deal with two operating systems. I also have another problem. There are certain apps, okay? There are certain apps. The way they work on Windows is very different from the way they work in Mac OS. Did you understand what I said? Even Microsoft Word differences are very small, but still the interface of Microsoft Word on Windows versus Microsoft Word on Mac OS is quite different. Not quite different, there are differences. Everybody okay with this? So I had to go for a Mac OS so that I get familiar with that interface as well. So when students ask me questions, I can help them because I'm familiar with the Mac OS. Everybody okay with this? I had to go with two laptops, two separate laptops, and I told you all what the problem is. Everybody okay with this? Now, guys, girls, everyone following with me, right? I'm coming to a certain point, okay? So everybody, can I look at this diagram over here? I'll send you all the tute shortly, or I'll send it to you all now itself. Everyone, can I look at this diagram over here? After you all take it down. For now, just look at my screen. Do you all agree? Everyone look over here. If I were to zoom in over here, can everyone look at the left-hand side only? For now, just focus on the left-hand side. This is how all our traditional computers are. All our computers that we use in today's world are following this architecture. You have your hardware, like what? Your motherboard, your processor, your hard disk. You have all your hardware components. On top of those hardware components, you have an operating system. You have a operating system. And on top of that operating system, you will put various applications. Agree, everyone? This is how all our devices are in today's world. You take your tablet, you have only one operating system in it. You take your smartphone, you have only one operating system in it. Everybody okay with this? In today's lesson, guys, we are going to learn something called virtualization. Virtualization is where you have one computer. You have one computer. You have one motherboard, one processor, one storage. Everything is one. On top of that, you have something called a virtualization layer. And on top of that, you can have multiple operating systems. Everybody okay with this? So you switch on one laptop, but then from that one laptop, you choose the operating system you want to work with. You get it, guys? Doesn't that really solve my problem of having two laptops? Okay, I was having two laptops because I want to deal with two operating systems. I want to familiarize myself with two operating systems. And you guys saw my problems, right? I'm having to charge two devices. I'm having to carry two devices, disk space of two devices. Is it clear? I have to purchase two devices. But over here, with this solution of virtualization, I have one machine. On that one machine, I have multiple operating systems installed. Are we all okay with this? Can you guys, everybody, can you all check this video out? Okay, so I'm going to show you a software called Parallels. Parallels was built for Mac. Okay, and now I want you all to tell me what you all see in this video. Okay, so guys online, again, if you have problems with your audio, you all need to tell me. So over here, we paste it. We mono. I think mono is a better option. Look at this diagram over here and see if it matches with what I have been telling you all. Okay, so you have your hardware. On top of that, you have a virtualization layer, a software that will help you to choose the operating system you want to use. Everybody okay with that? Then through that layer, you choose your operating system. Now, guys, you all follow this diagram. Every operating system will have its own set of apps. You get it? The apps over here do not mix with this operating system. You get it? Each operating system is having its own set of apps. Are we all okay with this? To give you all an example, guys, think about an apartment. If you take an apartment, guys, you take span towers, rush court, whatever, you take an apartment. Inside an apartment, you have multiple flats, or we say apartments. Is it clear? Each apartment has its own bedroom or bedrooms, kitchen, hall, washroom. You get it? So you have one big apartment, and inside that you have so many apartments. Is it clear? Virtualization is the same thing. You have one computer, and inside that computer, you have multiple operating systems that you can choose from. Are you all okay with this? So this is typically good for people who want to work across multiple OS. They are using softwares that need to be tested across multiple operating systems. Are we all okay with this? Now, guys, Microsoft Access, which you guys are using, is not supported on Mac OS. So if you're somebody who's having a Mac OS, you have to get Windows to use Access. So then I have had students who have installed Parallels just to use Access. So on their MacBook, they do everything normally on the Mac OS. Only to access Access, they change operating systems and they access Access. Okay? Are we okay with that? No, it doesn't. You need to have a decent amount of RAM, at least 8 GB RAM you need to have. Okay, and your storage also 128 GB won't do. You will need to have at least about 256 or 512 GB of SSD. Now, everybody, can you all draw these two diagrams in your computer? Inside hardware, can you all put down some notes, everybody? Inside hardware, can you all say motherboard, processor, hard disk, or SSD? Just tell yourself what hardware is. Guys, could you all hurry up, please? Okay, so when I say hardware, what am I talking about? So I'm talking about, motherboard, processor, storage, power supply. These are what I mean by hardware, okay? Now guys, while I'll do this, I'm going to try and get my tab fixed. So you all draw this. Come on guys, everyone, I'm giving you all 2 minutes to draw this. So you have your fixed hardware on top of this. So this on the left-hand side, we have traditional machine architecture. Normally, our machines are built in this way. Then if you were to follow a virtual machine architecture, you would have your hardware. On top of that, you would have a virtualization layer. And then through the virtualization layer, you choose your operating system. So guys, while you're writing, could you all just give some attention to me? While writing, just listen to me. You know why we are saying virtual? It does not physically exist. You get it? It's not online. You don't need to be connected with the internet. Virtual as in only on your computer it exists. You get it? Okay, this operating system, there are many of them. They only exist on your computer when that virtualization program is available. Okay, so we call it virtualization. It's only available through your computer. Come on, everybody. We have 30 seconds to go. Right, I'm going to move away from here now. Now, can everyone start reading with me? Still drawing? Done now? Okay. So everybody, guys, girls, everybody, you all saw in the previous video when I showed you all parallels, you had to switch on your laptop. Everybody, where was it? Sorry, here. Okay, so everyone over here, when I showed you all parallels, everybody, you all had to switch on the laptop. Mac OS loaded, isn't it? The Mac OS loaded, and then after Mac OS loaded, you all open the program called Parallels and choose the operating system that you all want. Everyone agree with this? Okay. Then guys, can everyone read virtualization now? The meaning of it is like having multiple computers inside one real computer. The analogy that I gave you all is it's like having multiple apartments inside an apartment. Okay, you have one big apartment and inside that you have, we say, flats or we say apartments. Okay, so instead of buying separate physical machines for each job, we can run many virtual machines. Okay, we can run many virtual machines on a single powerful computer. That's a bit important. Okay, Joel, you told me your computer needs to be powerful to deal with virtual machines. You have a small storage, a small RAM, a small processor running multiple virtual machines. Obviously, you can see the problem over there. Are we good? Okay, right. Keep reading it. Think of it like having many separate rooms in one big building. Each room can be decorated and used differently, but they all share the same main structure. Okay, or you can think of the apartments example. Okay, keep reading it. There are different types of virtualization. You have something called desktop virtualization, storage virtualization, network virtualization. I'll give you guys a very simple example. Everybody, in your computer, now in my laptop, I haven't done this, but many of you would have done this on your devices. You have only one SSD on your laptop. But if you go into File Explorer, some of you all, what have you all done? Some of you all over here, you all might have broken your one physical SSD into multiple what drives? They are not physically broken on virtual drives. So we say logical drives. Using computer logic, you broke it up. But if you open up your laptop, you only see one hard drive. Agree? If you open up your laptop, there will be only one hard drive. But using a program on your laptop, you broke that one physical hard drive into separate virtual or we say logical drives. Now, do you all agree? Even though it's one physical hard disk, your logical drives work independently of each other. Say, for example, I have local disk C, local disk D, local disk E. The files, physically, they are all in one place, but logically, they are all separate from each other. You get it, guys? You all agree with me, right? Even though it's one physical hard disk, logically, in the computer's memory, there are three separate hard disks. Are we all good? Right. Now, I want to show you all something else as well. Can everyone have a look at this? Where is it? Now, everyone, this is a bit, now we're going to get deeper into it now. Just check this out now. Again, I'm asking you, how did parallels work? You switched on your laptop, operating system loaded. After Mac OS loaded, you opened up a program, and through that program, you chose the operating system that you want. Agree with me, right? Check this out now. So we have something called hyperware. Okay, everyone. Or we call it VMware. Okay, we have something called hyperware or VMware. Difference. You all need to take this down in a little while's time. Can everyone read this? We have a program called a hypervisor. It's not there in your notes. What does a hypervisor do? A hypervisor allows you to run multiple virtual machines, or a hypervisor will allow you to switch between virtual machines. Are we all okay with this? Right. Can you guys read it? So we have allows multiple virtual machines to run on a single physical computer. Okay, so what does it do? The hypervisor is responsible for giving each virtual machine proper processing power, RAM space, storage space. The hypervisor is responsible for that. Okay, now we have two types of hypervisors. Boys, girls, can you all see the first one? Bare metal hypervisor. Can you guys read this and see and tell me whether it matches Parallels or VMware? The answer is there, but runs directly on the physical hardware, which means this hypervisor will tell you to choose your virtual machine when? As soon as you switch on or after loading the primary operating system. As soon as you switch on, it asks you choose your VM machine or choose your VM, which is virtual machine. Everybody okay with this? Parallels is known as a hosted hypervisor. It's running on an operating system. It's running on macOS. Through macOS, you choose the operating system you want to load. Are the differences clear over here? Okay, guys, you all need to take this down because this is not there in your note. The reason I'm giving this to you all is because we will keep using this word hypervisor. Okay, can you guys quickly get this down? First, get this area down below. On your writing books, I don't think you'll have space on your notes. You'll have, but get it down somewhere. Come on, guys, I'll give you all 2 minutes for the first part. So you need a hypervisor in order to manage your virtual machines, in order to give processing power to your virtual machines, in order to give space for every virtual machine to work on. You need a hypervisor. Okay. What is the purpose of a hypervisor? It allows you to run multiple virtual machines on a single computer. Okay. Come on, guys. 10:07 we move. Then we have two types of hypervisors, your bare metal and your hosted. So for operating system, you can put OS, try to make it fast for yourself. We now know what VM stands for. VM is a virtual machine. Okay. Types, first get the first part down, look. Okay, we'll take the types a little later. Come on, guys, 30 seconds to go. The types will take it a little later. For now, just take this first part down, look. Okay, so remember, you need a hypervisor in order to have virtual machines, in order to run virtual machines. There are two types of hypervisors, the hypervisor that loads at boot up itself and the hypervisor that loads after your operating system is loaded. The two types of hypervisors, we'll take it down a little later, okay? Everyone, 10 seconds to go. Right. So everybody, the first type of virtualization we're going to deal with is, everybody, we're going to deal with something called desktop virtualization. Everyone okay with this? Now, guys, if I were to ask you what is a desktop, you normally would come to this particular screen. Okay, you would say this is your desktop. But I want to add a few more things over here. When we say desktop, we're talking about your personal files. We're talking about certain softwares that you access. Is it clear? Your desktop basically consists of your settings and your files. Everybody okay with this? So when I talk about desktop virtualization, I'm talking about having the ability for you to access your desktop from any device. Now, what is a desktop made up of? Your files, your settings, your programs. That's what we call your desktop. Okay, so I'm talking about you having the ability to access your desktop from any device. Okay, we'll see what this is all about. Okay, so guys, sorry, any desk. No, any desk is sharing your screen. No, not share. You can't access now. For example, any desk. Yeah, they are controlling your PC. Yeah, I'm not talking about that. I'm talking about you check this video out below and then see if it matches with any desk. Everyone, can you all read this with me? So can everyone come down to desktop virtualization? Desktop virtualization allows a user's desktop environment, that is their operating system, their applications, and their files to run on a central server instead of a physical PC. Is it clear? Your entire desktop is on a server. Everybody okay with this? And then you access You access that data from any connected device. You get it? Your files, your applications, and your settings, you access it from any device connected to the network. Okay, I'll give you all a video. Users can access their desktop from any device with an internet connection. Are we all okay with this? I'll give you guys a very, very simple example. Okay, now can everyone check this out? Can everyone check this out? Now, all of y'all over here, we have a device called a thin client over here. It's a very small device and its resources are minimum. It has a very small amount of RAM. It doesn't have a graphics card even. Its processor has built-in graphics card. It has a very small processor. Storage is very minimal. So what do you think about the purchasing cost of this? Purchasing cost is very low. So how does this work? Now, for example, let's say I'm having a computer lab over here. Okay, and say, for example, the teacher has a server computer. All the students, let's say we have 45 computers over here. All the computers will have a thin client over here. All the student computers will have a thin client. All these thin clients will be connected to my server. This thin client will be used just to start up your device. All its resources, the desktop, the files, the applications, the storage, the RAM space, all that will be coming from my server. Everybody okay with this? It might be a bit difficult for you all to comprehend right now. Check this video out. Okay, what we're going to say? You all get this thing? eSoft, I don't think so. Okay. Small computer. Okay, then could be. So everyone, boys, everyone, can you look at this diagram? Okay, so you have your thin clients, basic computers, very cheap in cost because their specifications are minimal. They are getting all their resources from the server. Now, each of you all have a desktop on your device. Each of you all have a desktop, right? Which you will access with a username and password. Each of you, your desktops are stored on this server. Are we all okay with this? Your desktops are all stored on this server. Is it clear? So when you switch on a thin client which is connected to the server, you will put your username and password and access your specific desktop. Everybody okay with this? It's like this. When I run a computer lab, guys, I want all of you all to have the same settings. I want all of you all to have the same programs. Is it clear, guys? So I need one computer that can control all your computers. You get it, guys? So then this sort of a solution is extremely good. If I give all of you all your own powerful PCs, I'm going to have problems. You always start downloading various programs, taking up the storage space, putting your files. I'll have lots of problems with it. But if I give all of you all the same settings and I control it from my server, I have better control over the computers. Everyone okay with this? So now, do you think an office environment would use something like this? Office, no, because each employee has different needs. Okay, and each employee, their job description is different. Some are designing, some are in accounting, some are in sales, isn't it? So then this such a structure wouldn't work. But when everybody is doing the same thing, okay, like a computer lab, this sort of a structure is ideal. Check this video out. So where are we? So now they are showing you the setup, okay, how they set it up for users in a computer lab. Keep reading it now. I'll just show you all this also. This is a much bigger computer lab. Check this out. Okay with desktop virtualization then? Can everyone read that to yourselves again? The real life example. Hima, all of you read that with a real life example. A company uses something called VMware Horizon or Citrix virtual apps and desktops. So employees can log into their office desktop from home, ensuring they have the same applications and files without needing a powerful computer at home. Now, typically, we don't allow them to use it at home because security can be also a reason. Also, guys, loading a desktop, do you think it's something small in size? It can be a problem, okay? Where employees will say, you know what, you need to also provide us with data allowance after that. Employees might also say, you know what, my internet router is not internet router, I mean my data package at home is not enough to handle an entire desktop, loading data for desktop. So then it becomes other problems, more running costs for the company. Okay, everyone okay with this? And normally, guys, in a company, every employee has a different job description, right? So the apps they need, the files they work with, the environment that they work is going to be different for every employee. Agree? So typically for a company, it doesn't work. But for a place like a computer lab, or if you have a group of employees all doing the same tasks, then such a setup would work. But when you have a company of employees doing different things, then running a desktop virtualization doesn't really make sense. Okay, then can you guys read storage virtualization? Everyone read storage virtualization. Pools physical storage for multiple devices into one virtual storage system. Everybody okay with this? You have multiple hard disks, okay? But when you look at the computer, it shows you only one hard disk. Everybody okay with this? Anyone remember anything that we spoke about from 8As? We learned about a storage system where you have multiple storage devices. You may store the same data across all of them, but they all appear as one storage device for you. NAS, anyone remember? Network attached storage. We had another one, RAID, redundant array of inexpensive disks. Everybody okay with this? Look at this image over here. Look at this image over here, boys, girls, where is it? Everyone look here. This is a gadget you can connect to your home network. When you connect it to your home network, you will see one storage device. You will see one storage device in your home network. But inside it, you have multiple hard disks. So through the process of virtualization, it took multiple hard disks and pulled them together as one storage device. Are we all okay with this? Okay. Can you guys keep reading it? Okay. This improves efficiency and flexibility. Can you guys look at a real life example in a data center, in a place where now we are all okay with data centers, right? Or you can, to make it easier for you, let's say data warehouse. In a data warehouse, you're accessing one warehouse, but behind the scenes, you might have a collection of storage devices collecting this data. Everyone okay with this? You might see one data warehouse, but behind the scenes, there are a collection of hard disks storing the data on your data warehouse. Keep reading it. So using something called IBM SAN volume controller, whatever. So IT administrators can manage all storage as if it were a single large hard disk. This helps allocate space dynamically to different applications. Do you all understand that last part? You have a collection of, we'll say for example, 10 500 GB hard disks. For one, now you have a collection of 10 500 GB hard disks. It's going to show you as one storage device, right? It's going to show you as one storage device. So it will tell you now you have a 5000 GB storage space. It will tell you now have 5000 GB of storage space. Now, can you guys read this last line? This helps allocate space dynamically to different applications. Let's say you have an application that requires a space of 525 GB, but your hard disks are all 500 GB only. So this application is not going to work on any of the hard disks, right? In a normal scenario, you have only 500 GB hard disks you have, but there is a particular program that requires a space of 525 GB. In a normal scenario, you can't, this is not going to work. Your hard disk maximum capacity is 500 GB. Program requires 525 GB. But if you were to do storage virtualization, what happens? You have combined all your hard disks and made what? One virtual hard disk. Now this 525 GB program, can you store it now? You can now store it because you pooled together many storage devices and made it logically one. Are we all okay with this? That's what this last sentence means. Okay? Then guys, can we read the third one, network virtualization? Network virtualization lets one physical network act like many separate networks. Everybody, do you all remember when we spoke about the impact of big data? And when we came down to storage, I gave you all some examples of what? Amazon Cloud Services, remember? Amazon Cloud Service or Amazon Web Services? Amazon Web Services, right? So Amazon said what? We don't only provide you the storage, we also give you the tools to work with your storage. We give you the infrastructure to work with your storage. Is it clear? So inside that massive Amazon network, you have so many small networks that are all separate from each other, but they are all inside one network. Do you understand what I'm saying? I'm saying the opposite in the same sentence. You have one network, but inside that one network, you have so many networks. And each network is isolated from the other. Everybody okay with this? So Amazon has one infrastructure of a really powerful network with its own hubs and switches and bridges and servers and all that. And then what do? Depending on the subscription fee that you're paying, they give you a private network. Everybody okay with this? That's what we call network virtualization. Inside one massive network, you create so many private networks. Okay, so physically it's one network, but virtually you create so many private networks. All good? Can everyone go to the addition? Are you with me? Okay, so look at the example over here. AWS uses something called network virtualization to give each customer or each client, each company their own secure virtual private network. Okay, everyone okay with this? Or we say virtual network inside the same physical system. All good? So everybody, are you okay with virtualization now? Okay. So what do you think about virtualization? Extremely popular in today's world or very popular in today's world? Okay, everyone? Yeah. Yeah, that is also possible. For example, if you are a developer, you want to test your programs on different operating systems, right? Before you release it. Okay, so rather than you buying separate laptops with different operating systems, you have one laptop. On that one laptop, you will have a hypervisor that will allow you to switch between operating systems. Everybody okay with this? Okay. Then everybody, can you come down over here? We hung all of you. Come on, guys. Can you come down to benefits of virtualization and see if you all agree with them? Number one, cost saving. Fewer physical machines are needed. Think about my laptop problem. Instead of buying one laptop, I could have managed with one laptop, no? Agree. Think about servers. Think about a computer lab. Instead of buying powerful computers for every user, I just buy a thin client for everyone, which is much cheaper. Okay, so cost saving, number one. Number two, better resource utilization. You're making full use of your storage. You're making full use of your RAM. You're making full use of your what? Graphics card, your power supply. Is it clear? You're not running one operating system. You're running multiple operating systems. You'll agree with me on this. You're making full use of your resources. Okay? It's like, for example, guys, inside a building, you can have one family, or you can have inside the building, you can have 10 families. In which one are you making full use of your resources? The one where you have put 10 families inside, isn't it? Inside one building, yes, uncomfortable and all is different, but you're making full use of your resources. That space, you have put 10 families inside. Everybody okay with it? So the same example, put it with computers. You're making full use of your available resources. Okay. Next, flexibility and scalability. What do you mean by scalability? I told you all. So in this example, we're talking about what? Not storage. So what's a good word for that? No. Your virtual machines, you can increase, decrease as you wish, isn't it? It's not too difficult to add a new virtual machine. It's not too difficult to remove one. Flexible and scalable. Okay. Isolation and security, you'll understand that, no? Each virtual machine or each virtual network or each virtual desktop is separate from each other, even though they're all on the same storage. Okay, even though they are all physically in one place, they are virtually or logically separated from each other. They don't interfere with each other. Exactly, it doesn't. But we are coming to that. I'll tell you another problem on the other side. Everybody, boys, one virtual machine having a malware will not affect the other virtual machines. Okay, you'll agree with me on that? One virtual machine having a problem will not affect the other virtual machines. Exactly. Coming to that and drawbacks. When we come to that, we'll talk about it. What if the server got affected? Faster deployment. You can have a new system, a new virtual machine up in minutes. Energy efficient. Okay. You're using one electricity supply to run many machines. Cross-platform compatibility. Understand that now? You can test your programs on multiple operating systems using one device. Okay. Look at your drawbacks, guys. Look at your drawbacks, everybody. You need an extremely powerful device. When we say a powerful device means what? High RAM capacity, high storage capacity. Okay. Possible performance drops. Sometimes one virtual machine might pull more resources, affecting the other virtual machines. Are we all okay with this? High initial cost. You need to buy a powerful device. Not easy to set up. It's a bit complex. Okay. Security risks. Vihanga, you brought this up. If the server gets affected, or say, for example, on this laptop, I'm running 3 operating systems. If this laptop breaks, what happens? All 3 virtual machines are unusable. Okay. Think about the computer lab, server goes down, all your desktops are inaccessible. Okay. Software licensing issues, that's very true. Okay, everybody, you know the problem there, right? When you buy a software, it's valid for a device, but typically a device consists of how many operating systems? 1. So when you buy a software, it's normally for 1 operating system. So even though you have multiple virtual machines on one device, you need to get a separate license for every virtual machine. Okay, so problems over there as well. Keep reading. Single point of failure. Where is the failure? The host computer, server computer gets messed up, the whole thing goes down. Guys, can you go from benefits to drawbacks again, top to bottom? I'll give you all 1 minute. Okay, and I'm going to show you another video to change the mood, obviously. Vihanga, you're supposed to be reading. So everybody, let's change the topic for a while before we go on to the next part. I think I have shown this to you all previously. Have I shown you all this? Specially able. I don't know, y'all check on it, but there is a term for it. Guys, something else came to my mind. All of y'all, everybody, I haven't tried the platform yet, but I would recommend you all trying it out. So this guy, Nas Daily, he has put out a platform called nas.io. It's a collection of, AI operators. Let me show it to you all. My wording is quite bad. Okay. If any of you all want to start something on your own, everybody, I would first recommend learn how to use AI. Is it clear? Because there's so much AI can do for you. I'm like right now using ChatGPT heavily. I'm using it when it comes to preparing my lessons, when it comes to finding videos, sometimes certain explanations. I wonder, how do I put it across to you all? I just asked ChatGPT, how do I get this across to students? Give me a good example. It gives me a good example. I use it for so many things. Similarly, guys, what this guy has done is he has put out a platform called nas.io. It has a collection of AI tools that you can use to build whatever you want. You want to do video editing, you want to create videos, you want to create content, okay, whatever it is. Okay, there are so many things you can do over here. So if you want, guys, he's charging $1 a day, where he will train you to use different tools, and then you can build whatever you want. Okay, and it has the tools for you to build a website, to start selling, payment gateway, all those tools it has. Okay, so for the training, he's charging right now, I think $1 a day or something like that. But what I would recommend is start off with the free one. Start off with the trial, see what features he's offering. I wanted to explore this. I didn't explore it yet, but I've been seeing a few videos about him talking about this. It has some AI tools in it, or lots of AI tools in it, that you can use to build whatever you want to sell. Everybody okay with this? So whatever it is you want to sell, for example, you want to teach people how to dance, you want to teach people how to sing, how to play a particular instrument, or you want to teach them ICT, I don't know, whatever it is that you want to sell, you can use his platform to build whatever you want to sell. You get it? So you tell AI exactly what you want, it does it for you. And then you start optimizing. No, remove this, add this, construct this, put it this way, put that color. You get it? So for example, building videos. Guys, have you all seen these AI generated videos on TikTok now? It's like how, what to believe in today's world, right? Sorry? I don't know. Like, right, when I look at those videos, I get scared. Like, now, what do you believe? What is true? What is not true? Like, they take a AI video of Obama saying something. And because I know, I'm a bit suspicious. But if somebody didn't know, they would believe Obama actually said that. Everybody okay with this? Sorry? My mom did that. Yeah, same for me also. Everybody okay with this? So I didn't, everyone, do check this tool out. Okay? You will be able to make use of AI to build your own product or your own service. So it goes as nas.io. Now there's a high chance if your phone's mobile data is on, to have heard these words, and now you guys are going to see ads for it. Okay, there is a possibility that you all might start seeing ads for NAS. Okay, he's running a lot of ads right now, promoting it heavily. I'm not recommending, I'm just saying this is one tool. Check it out and see if it works for you all. Okay. All right, everybody, can we move on to the next part? Everybody, can you all come down to the next part? Achieving virtualization. Now, everybody, we hung all of y'all. We spoke about virtualization right now. Can you guys read this? There are two methods. There is something called virtual machines and there is something called containers. A little confusing things are going to get right now, so bear with me, okay? Can you guys read first what are virtual machines? Joel, all of you, Lishan, all of you. Act like a complete computer inside an existing computer. Agree? Virtualization is where you have a virtual machine. It's like a computer inside a computer, just like the apartment example. An apartment inside an apartment, or apartments inside an apartment. So every virtual machine has its own operating system. Just like every apartment will have its own kitchen, its own rooms, its own hall, its own washrooms. Everybody okay with this? Its own electrical system, isn't it? Every apartment has its own electrical setup. Okay, that's what you call a virtual machine. Now, guys, girls, think about this. Before I'll read containers, guys, I want to give you all a real life example to make it a little easier to understand containers. All of y'all, if you cook your food at home and come, you buy a ready-made meal. You buy a ready-made meal, okay? You order something on Uber Eats, it's ready-made. So no matter where you go, you can have your meal. Do you depend on the location to provide you with utensils to cook it, to mix it, to heat it? No, it's a ready-made meal. You can start having it wherever you are located. Another option is where you bring the ingredients and you cook your meal. Is it clear? Now, say for example, for your break, when you bring ingredients here and come, you depend on Platinum to provide you with the tools to cook. Agreed? Everyone, that makes sense, right? You can bring a ready-made meal for your break. You can have it in any classroom. Not a problem. But if you bring the ingredients and come to cook your meal, you depend on Platinum to provide what? The utensils, the tools, the microwave, the oven and all that in order for you to mix your ingredients and have a meal. Everyone okay with this? Right. Just keep that example in mind. Just keep that example in mind. And can you guys read containers now? Focuses on running a specific program or function. They don't need a full operating system and are light and fast and virtual machines. Makes no sense at all right now. Okay, because I haven't explained what containers are right now. Now, everybody, in AS level, you all downloaded Sublime Text now. Okay, so you all went to Sublime Text website and you all downloaded a setup. Is it clear? When you all downloaded that setup, it's basically like you all downloaded the ingredients for Sublime Text. Then when you installed Sublime Text on your computer, using your existing storage, using the libraries and settings available in your laptop, Sublime Text was installed on your device. Everybody okay with this? I'm repeating myself again. When you all downloaded Sublime Text, you all only downloaded the setup. It's like you all downloaded the ingredients and then your computer made it for you. Everyone okay with this? Now, we have another version where we give you a ready-made software. So this software can run on any environment. On any device, it can run. It has everything in it for it to run on any environment. Everyone okay with this? I'm giving you a software setup, and in that setup, I'm giving you all the tools that you would need in order to install this software on any environment. That is what we call a container. A container is where I give you the software setup And along with the setup, I also give you all the tools, the settings, the libraries, whatever you will need so that you can run this software on any environment. Everybody okay with this? There's one more confusing thing coming up, which I will bring it to you all in a little while's time. Can everyone come down to virtual machines now? Boys, everyone look here below. This Himakala fell read it me below. Now, can you all look at the first column? Virtual machine, full hardware virtualization. Okay, reads the next one. Every virtual machine has its own operating system. Agree with me on that? Every virtual machine has its own operating system. You need a hypervisor in order to run your virtual machine. Agree? The words are a bit complicated. I took it for the textbook. Okay, can you read the last one? You can run multiple virtual machines, each virtual machine having a different operating system on a single physical machine. Agree with me on that, no? Everyone agree with me on that? Okay. Can you guys read the containerization side? A container, does it require an entire operating system? No. A container is only an application. It's only one particular software. A container is one particular software. It doesn't require a separate operating system and isolated space and all that. No. Keep reading it. It has the application and any dependencies, any settings, any tools is inside the container. Okay. It shares the, you can ignore that for now. Okay. Smaller footprint as only, so guys, do you know what smaller footprint means? Why smaller storage? Every virtual machine has its own operating system. Every container does not have its own operating system. Every container has only the application and the tools for that application to run. So obviously a container is much smaller in size than a virtual machine. That's what they mean there. It's in confusing words, but you all do understand that, right? Could you all just put in small words, smaller in file size than a VM? Just make it easy for you all to understand over there. Smaller in file size. Then VM. Okay? Yeah. Yes, everybody, guys, girls, all of y'all, can we keep moving on to the next one? Can you all see in terms of resources used? Boys, can you all have a look at in terms of resources used? A virtual machine will be consuming way more resources. 1 second, let me put this on. So each virtual machine has its own allocated amount of RAM, processing power, storage. So a virtual machine consumes a lot more resources than a container would consume. Okay. Requires more time to start, obviously, because of its file size. Okay, a VM will take more time to load it because it has to load an entire operating system. Okay, Dishan, all of y'all with me? And then can you compare that with containerization? It's a specific program. It's just one program that contains all its dependencies. Okay, so faster startup times, reduces resource consumption. Okay, look at isolation, guys. Each virtual machine is a separate machine, virtually, not physically. Okay, and it is suitable for running applications that require different operating systems. Now, containerization is a storage separate. Every what do you call the container? Adam, are you with me? The programs are all running on one storage device. Okay, so there isn't much isolation. Okay, one programming changing could affect the other files in the same storage. Obviously, no. Okay, keep reading it. Isolated from each other, but they share the same resources. Okay. Higher risk of security vulnerabilities if not configured properly here. Can you guys see portability? Now VMs, guys, you're installing it on a particular computer. So that VM will work only on that computer. Agree? A virtual machine will work. You're installing it on a particular computer. So it will work only on that computer. You can't move it to another computer. Okay? But containers, it's a specific program. You can put that program on whatever computer you want. So much more portable. And since they have the application and all the dependencies in it, it can run on almost any computer. Okay, can you guys see where we use it? Everyone, can I go through the places where we use containerization and where we use virtualization? So virtualization is best used for running applications that have a variety of OS requirements. Okay. Containerization is normally used for cloud native applications. Okay. Where, for example, you do not know what type of users will be accessing this application. Each user will be having a different computing environment. Okay. So on the server, you put a containerized application. Okay. Containers are, for example, imagine you have the application and you have all the dependencies along with the application. So this application can run on any runtime environment. It can run on any computer environment. You get it? Okay. So you can put this program on any computing environment, it will be able to run because it has all its dependencies. You can say it has all its tools along with the application. Okay. So typically for cloud programs, we use containerization because we do not know what type of devices will be accessing the cloud to access this app, right? So on the cloud, we put it in a container and keep. So it can run on any computer. Okay. Are we okay with this, guys? There isn't much over here. Virtual machines versus containerization. All good? Okay, I'm going to move down. Everybody, can we come down to distributed systems, everybody? We have already spoken about distributed systems. It's again coming up. What do you all know about distributed systems? You're storing the same data across multiple storage devices, multiple servers. Okay. We have done this in data manipulation also. We spoke about doing this because we want to reduce traffic. We want to increase the available time, the uptime. We want to deal with fault tolerance. Isn't it? Can you guys go through this? Again, you're going to be talking about this. Is made up of multiple computers. Each computer is called a node working together to do a job. Okay. These computers might be in different places and they might be using even different hardware. Okay. But they all act like one big system. You see it as one system, but in the background, it might be many systems working together. Okay. Keep reading it. See the example I have given you all. Google search. When you type something into Google, you might be dealing with many servers, but what you see is one Google platform. That's what you see. Okay. Okay. Right. Can you guys keep reading this? Because of the many benefits they provide, distributed systems are becoming increasingly popular with large organizations. Benefits we have already spoken about in data manipulation, like what? High fault tolerance, high availability, high scalability. You can add and decrease. I mean, you can increase and decrease as you want, high flexibility. We have already spoken about it in topic 12. We will again talk about it again. Okay. I'm going to give you all a few examples of where they are used. Can everyone come down to web services? Can you guys first read it? Web services use computers in different locations around the world to deliver online services faster. Okay, the system chooses a server that is physically closest to you. So let's take an example. Can you guys see Netflix? Netflix's headquarters is in the USA. When you stream in Sri Lanka, your movie comes from a local Netflix server somewhere in Asia. Exactly where, we don't know. Okay, but they will be choosing the closest server to your physical location to send the data. Everybody okay with this? So then streaming time is going to significantly reduce. Are we all okay with this? Instead of taking all the streaming services from one server in USA, you have stored the server. Adam, are you with me? Okay, you have stored your data across multiple servers in different parts of the world. Okay, this makes it load faster and avoids buffering. Then can you guys come down to data services? Data services stores and copies data in different places, so it's safe and easy to access. If one place fails, the data is still available from another. This is what we call high fault tolerance. If one fails, the others will still keep the system running. Okay, can you guys read the example? Google Drive, OneDrive, Dropbox, your data, you see one platform, but in reality, in the background, behind the scenes, your data is stored across multiple servers. Yeah? I don't know. Maybe we have, maybe we don't have. Those are things normally a company wouldn't tell where their servers are located, especially in a country like Sri Lanka where our data protection acts are not very strong. They may not choose to tell it, but maybe they are, we don't know. Okay. Your files are stored in multiple data centers. If one center has a problem, your files can still be opened from another location without you noticing. It will never tell you redirecting you to another server. It just happens automatically. Then can you guys goes down? Can you guys go to the third one, blockchain? Do you know where we pick up blockchain from? Cryptocurrency. Now, guys, when it comes to our traditional fiat currency, LKR, US dollars, all our data is stored on a central server. So any online transaction you pay goes through that particular server. Everybody okay with this? We all use online banking. No, in online banking, all our financial data is stored on central servers. So whenever you make a transaction, it has to go through that central server. Okay, if I transfer money from my account to somebody else's account, that transaction is recorded in a central server. Everyone okay with this? But when it comes to cryptocurrency, we have something called a blockchain. Every computer on this cryptocurrency network will store the transactions that took place. Do you all understand the difference? In fiat currency, the currency that we use to buy and sell, all our data is going through a central server. But in cryptocurrency, they have something called blockchain. Every transaction that takes place gets saved on every computer on the network. So if somebody wants to modify, they have to modify how many computers? If somebody wants to hack it and mess it up, they have to go and basically hack every single computer like that. Okay? It's quite difficult for them. Okay, can you guys go through this? In blockchain stores records in many places at the same time. So no single location has complete control. Yeah? Bitcoin, yeah, because central, it's all in the fiat, now dollars, LKR and all is fiat currency. In that, everything is stored to a central system. So it can always be traced back to you. Whatever transaction you do using fiat currency can always be traced back to you. But in cryptocurrency, it's very difficult to trace it back to you because every user is given a unique ID. They don't ask you for your name. They don't ask you for your location. They just give you an ID. That's all. Okay, so it's very difficult to trace it back to you. Can you guys read the example I have given you? Every Bitcoin transaction, every cryptocurrency transaction is stored on thousands of computers worldwide. Okay, to hack it, you have to change the record on every one of these computers, which makes it almost impossible for you to hack. Is everyone okay with this? Okay, which is nearly impossible. Okay, right, everybody. Can you guys come down to your benefits and drawbacks, and then we'll be done with this particular part also. Benefits: faster performance, you understand, right? Processing is done by multiple computers, or you can say, how can you say faster performance? Number one is processing is done by multiple computers, or you can say shared. That's what I just said. Traffic is shared, right? You're not dumping all your traffic on one server. You're distributing your traffic. Number two, scalability. You can increase and decrease as you wish. Fault tolerance. One server being affected by a malware doesn't affect your whole network. Okay. High availability. One server going down doesn't cause your whole server to crash. Your server will still keep, your network will still keep running. Okay. High availability. Look at your drawbacks, guys. Very complex. Setting it up, maintaining it can be very complex. High security risks. What do you mean by this? You have multiple entry points now. You get it? In a distributed system, you have multiple servers to try. Okay, one server doesn't work, you have another server to try with. You have multiple entry points. Data consistency issues. What was this problem? We spoke about this problem. You need to multiply, you need to update all the servers at the same time. We were calling that not redundancy. Concurrency, updating all the servers at the same time with the same data. That's concurrency. And if concurrency doesn't happen, what does it lead to? Data inconsistencies. One server is saying one story, another server is saying another story. Which one is the right story? You don't know. Are you okay with this? Number four, network dependency. Everyone, can you read that? The entire network, you have multiple servers, but they all depend on the internet for them to operate. Everyone okay with this? Not a very strong point, but can be taken. higher costs, okay, more servers, more storage, more bandwidth needed, more network equipment needed. Troubleshooting can be difficult. Finding where the problem in your network is occurring from can be complex to understand. Guys, I'll give you all 1 minute. Can you go through the benefits and drawbacks? And then can we go to topic 12, part 3, everybody? 1 minute here, and then topic 12, part 3, please. We will come back to these questions after we finish topic 12, part 3. Okay. So I'm going to close this now. Topic 12, part 3, please. Everybody, can you all come down to question number 2? We just spoke about this. We just spoke about this. The company's big data operations use a distributed system. We just spoke about distributed system. Okay. Describe what is meant by the term distributed system. What do you mean by distributed system? When a company's data is stored across multiple servers, multiple storage devices on multiple servers. Can everyone get that down? This is a system where data belonging to a particular organization, data of a particular organization belonging to a particular organization is stored across multiple servers, and these servers are placed across multiple places in the world. Okay. To a particular organization is stored across or is stored in multiple servers, is stored in multiple servers. Okay. Where these servers are spread across various parts of the world, where these servers are spread in various parts of the world. Are we good? Where these servers are spread in various parts of the world. Boys over there. Okay. Adam, aren't you writing it down? Done? Imak, done? Okay. Then guys, one problem with distributed systems is controlling something called concurrency, which we just spoke about. Give one result or consequence of poor concurrency. They're giving you only 1 mark. It can lead to massive data inconsistencies if it doesn't happen properly. Okay. If concurrency does not happen properly, it can lead to massive data inconsistencies across multiple servers. Poor concurrency can lead to massive data inconsistencies across multiple servers. Are we all good? Poor concurrency, boys, can lead to massive data inconsistencies across multiple servers. Okay, all done. Shall we keep moving? So question 4, the first one we have done, the second one we haven't done, no? A company owns and operates airports in several countries. The company collects large amounts of data and uses big data techniques to analyze it. Okay, that was the main question. The second part of it is high capacity storage devices are required to handle big data. State one other infrastructure requirement for big data. High bandwidth networks. What else? You need massive amount of storage. So there were three things we broke up. We broke infrastructure into, what were they? Number one, you need to infrastructure, we broke it down into three parts, right? Before storage, you need to collect, no? So we had your collection sources, then we had your storage, then we had your transmission part. So he spoke about transmission. So you can talk about high bandwidth networks. High bandwidth networks. Can you guys just have a look at the marking scheme and see what else is there? High bandwidth network. Okay, what else? Have they allowed cloud storage also there? Question 4, second one. So the other answers that they have accepted is more processing power, softwares for analyzing. Again, they have mentioned storage, faster, higher capacity, which we wrote, wide area network or faster networks or higher bandwidth networks. Everyone okay with this? Processing power, can you also note down in your answer? Higher processing power. Okay. Higher processing power or high processing power. We'll do this and then we'll go back to, what shall we do? We'll do this B and then we're going to go back to topic 13, okay? The company relies on a suitable infrastructure, that is devices and connections, to make use of the data it collects. The infrastructure may develop something called bottleneck, okay? A bottleneck can be slow storage media at the company's data center. Everyone know what a bottleneck is? So a bottleneck is a specific point that slows everything down. Himak, are you with me? Okay. A bottleneck is a point that slows everybody down. So say, for example, guys, now when I tell all of you all to leave the classroom, from that point to this point, all of you are going to move really fast. But through this door, how many people can go? Only one person can go through this door at a given time. So what's going to happen? Everybody is going to come and slow down over here. So here you have a bottleneck. The traffic builds over here. It's like, for example, when you're on the road, okay, let's say, for example, you have a wide road, but then it narrows a bit at the end. So what happens? Vehicles are moving and then at where it's narrowing, everybody come and slow down over there. There's a bit of traffic over there. Sometimes this problem happens on a network. Okay, you have a fiber optic connection at home. Okay, that can operate at 1 gigabit per second. Is it clear? So data is loading really fast, but your laptop's network interface card can deal with a maximum of 10 megabits per second. So what's going to happen now? Data is coming really fast and then it comes to your laptop and slows down. Everyone okay? So a bottleneck is happening over here. Are we all okay with this? Okay, so sometimes this can happen on servers also. Okay, there can be a certain point in a server that's slowing everything down. Okay, that's what they call a bottleneck, a specific point that slows everybody down. Okay, can you guys read this? A solution for this bottleneck would be to upgrade the storage media from hard disk to SSD. Give one other possible infrastructure Give one other possible infrastructure bottleneck and a solution. So one is, one is change your storage. Change your storage media. We know, right? SSDs operate at a higher read-write speed than HDDs. We do know that. What is something else you can change? You have a problem of things slowing down, something that you can do to reduce this problem of slowing down. CPU what? Bandwidth can be adjusted, right? Okay. So you can say slow bandwidth. Bottleneck problem can be slow or limited bandwidth. We'll say slow bandwidth or low bandwidth. Processing power. So tell me the problem first, then give me the solution. Bottleneck can be what? Low processing power. Then give me a solution, increase the number of cores. Okay. I'll go with bandwidth. Okay. Processing data due to low transmitting of data at slow speeds. What would be your solution? Increase the bandwidth. Okay. Increase bandwidth or increase available bandwidth by using a higher end network, by using fiber optic cables. Or switching to 5G or using network interface cards that support a higher bandwidth. Okay. Okay, from topic 13, can we do at least one question before you guys leave? I'm closing this, guys. No time.